Hello again, and welcome to the Near Futurist podcast. My name is Guy Clapperton. Now, if you're a regular listener, you'll be well aware, painfully aware of what comes first. So here's a quick plug for my media training service at Clapperton Media Training. Do you want to sound as confident as my interviewee in this episode? If you talk to the press or other media, are you worried you'll be misquoted, or they'll just publish their story and not yours? Clapperton Media Associates can help with coaching. Drop me a note, guy@clapperton.co.uk, and we'll arrange a time for an exploratory call. Now, back to the podcast. And that's more than enough of that. Now this week, we're having a look at forecasting, predicting environmental and other risk, but using new and unique technology to achieve it. My guest company has recently raised around $4 million, and she's going to be a speaker at the Web Summit Rio in June as part of the energy track. Now, current Earth observation relies heavily on incomplete or inconsistent training data. In many environments, from remote forests to rare natural disasters, the real-world data needed to train reliable AI models simply doesn't exist. Now, my guest company fills those gaps by generating high-fidelity synthetic Earth observation data specifically designed for that AI training. Now, this allows organizations to move beyond analyzing what's already happened and instead simulate how environmental and operational scenarios could unfold in the future. The company is called Another Earth, and my guest name is Maya Pindeus, Chief Executive and Co-founder. Maya, welcome.
Thank you for having me. Hello.
You're more than welcome. Thank you for making the time. For listeners hearing about Another Earth for the first time, what exactly is synthetic Earth observation data?
Perhaps we start with just a quick bit of an introduction what Earth observation data is. So it's really information gathered about the Earth's physical, biological, chemical properties and primarily collected by remote sensing technologies, satellites, drones, or aircraft. So that means we collect the state of the Earth. We try to understand and receive and collect as much information as we can. The problem, however, is we need to actually understand what is going on and what has been going on, we need to be able to retrieve information from, let's say, satellite imagery, from Earth observation data. And this is where synthetic data comes in. For an AI system to be able to understand changes, understand what is going on the Earth's surface, it really needs to be able to read it, to understand what it is looking for, what it should be looking for. What synthetic data does is that it essentially creates imagery or Earth observation data that looks identical to real, but it isn't. It's actually generated by AI systems, really, generative systems. But it has all information encoded that a system needs to read, to train, to be trained to, for instance, then understand what is going on. I'll give you an example. For instance, if you're looking to understand power line extension, you're looking to understand the state or the disease for certain crop types. So if you're understanding the state of building infrastructure, for the AI model to understand that, to read that, it needs to be known what it's looking for. And that's essentially what synthetic data does.
One issue people have at the moment with AI in daily use, and I appreciate you're probably at a much more advanced level than most of us, is the fact that it hallucinates. So if, for example, the AI thought there could well be a river there, that looks feasible, it might just put a river in somewhere where there isn't one. I mean, how do you avoid things like hallucinations, and how do you preserve the integrity of the synthetic data?
I think a really important thing is to distinguish between the AI tools that we now, presumably almost all of us use in our daily lives, essentially generating responses to all the various questions we're looking to answer, we're looking to get help with, and then Earth observation AI. And that is very, very different because the Earth surface is so incredibly complex. You can't really drop the large language model there and looking to answer and everything because it is very difficult, very bespoke. So essentially, what that means for synthetic data and for the AI that or for the systems that we're helping to train, that we're developing, is that the information that we create, the synthetic Earth observation data that we create, needs to exactly match the target information, meaning target area, the target satellites, the target drone imagery, and you actually compare. And with that, you're making sure that, it works, it fits. But there's Another huge benefit, from our point of view, is that you are able to create really unbiased data, able to create large variations of data. Because again, an artificial intelligence model, learns best if it has all the possible scenarios or edge cases to learn from, which is again a benefit of generating artificially.
That is the politest way of telling me that you are not using ChatGPT. Who do I think I'm talking to? That I've ever heard. Quite right too. But thanks very much for that. So, can you be a bit specific about what sort of problems you're trying to solve that existing Earth observations don't? Because a lot of the forecasting out there is pretty good.
So, an Earth observation system, right? On one hand, you have the sensors, satellites, right? As one we're most familiar with, also drones and also aircraft that collect data. They collect heaps and heaps of data, which is great. So we have a beautiful inventory there. Then there are systems, technologies, and they're looking to extract information. Here is an object, here is a building type, here is a forest type, etc. Right? So essentially making sense of this information. What lies in between is the training a system to be able to understand what it's looking for and to be able to actually detect, classify, and predict. And this is where essentially we come in, or synthetic data comes in, because with all information is collected, it doesn't guarantee that an AI system is actually able to read and understand. So what we aim to do is to really shorten the time it takes to train a model, because you don't need manual labeling. You need to curate, you need to collect, curate, annotate, and then you can, traditionally you can train and apply. But with us, with synthetic data, you can actually generate the training data that your system requires quickly and with a large diversity and bandwidth, really. And with that, our aim is really to enable AI and Earth observation, bring down those barriers, because what we're seeing is that there's so much potential here today. If we had a more transparent view of a planet, we actually see what is going on, I think it would be a more responsible use as well. It would really help us take decisions. And if the industries at large, the Earth observation industry, touches almost everything around the supply chain, would have means to generate and create and apply models more quickly, we believe it would have a massive benefit. And that's really what we're trying to do, bring down barriers.
In the information I was sent beforehand, there was a lot of talk about helping organizations predict real-world risk before it actually happens. Yeah. Now, what sort of risks are we talking about?
Well, let's start potentially with environmental risks. If an organization is taking a certain decision, let's say building infrastructure, that's a very good example, what would the likely impact be on the environment? The environment can be the landscapes, and not the forests, landscapes, also built environment around what could the likely positive and negative impacts be, right? On the physical environment, but also socioeconomic risk, for instance, right? What could happen? What would likely be, changes in the demographics? So those are essentially being able to say, well, if we take a certain decision, this are impact ABC that we should be considering, and with that, should we take this decision or not? Then there's the more, the natural disasters. It's another one. Being able to predict or really create scenarios about likelihoods of environmental, of natural disasters, and being able to, where possible, prevent, mitigate, plan for. There's a level of, when the planet is changing so rapidly, that you actually require this level of visibility to plan for it. You can't always change it, sadly, but you can, adapt for it. And those are the risks that we're looking for often, yeah.
There is, on the other hand, quite a few people, some of whom might well be world leaders or significant presidents of significant companies, who see evidence and just dismiss it and decide that, for example, climate change isn't real. So is this going to be any more persuasive for that sort of attitude, do you think?
Well, I would hope so. One interesting argument there for, however if you, even for leaders or people that are less inclined and believe in the apparent and obvious, but they do care about the impact on their physical, call it assets, right? So if there's a storm, if there's a wildfire, if there's a flood, a lot of physical assets likely to be damaged with that, a lot of money lost. And that's probably the most persuasive argument for for everyone, right? So, and it's all connected, is clear to us, I would hope. But it's about providing a level of insight and transparency that helps everyone understand, and hopefully it will, allow us to then I think work a bit more together, even if the people might care about different impact, so about different sources, but the impact is I think yeah, it's very
Why
obvious,
did
undeniable.
Okay, why does historical data alone no longer sway people? Or will you be adding more information that we can get from historical data?
First of all, it's often incomplete. While there is a lot of satellites, more and more so, the drones, etc. I mean, a lot of is naturally gravitating towards the northern hemisphere, not the southern hemisphere, for instance, where a lot of our goods and commodities production, earth minerals, food are actually at abandonment. So there's a huge blind spots of areas where there's just not enough data. And not historical data you can't really use. So that's a huge problem. And even in areas that are very well covered, you might be surprised how things like clouds, things like not looking at the right things at the right moment are actually hindering the emergence of the possibility of building good monitoring, but also predictive models today. So that's one part. The second part is that the Earth is changing so quickly. It feels like every once a week, at least, with your new record of, it's the hottest month, the hottest year, the most droughts, most floods, most wildfires, etc. So the face of what we think or believe is normal, is what we're used to, changes, meaning that you need to accommodate for that in the data that you train your models with, so that the models are able to filter out and see and extract likely signs of well, let's say with natural disasters, for instance, right? So you can't really just rely on historical data, because what is normal changes, and it changes rapidly. And this is another big benefit of simulation synthetic data, that we're actually able to complement that, and hopefully train more resilient models with that are able to pick up on cues.
Are there any industries showing strong interest in what you're building? Which industries will benefit the most, do you think?
Well, I think primarily it's industries that are impacted by a lot of change, and are impacted by climate change, are impacted by a more volatile world, whether that's a natural disaster or geopolitically. They require more transparency, and they require more insight. I believe so. What we're seeing is definitely energy industry, right? Record storm can have a huge impact on energy supply and on the grid, right? So being able to anticipate that is very important, or even the usage of energy in Europe, but also as a beyond that, it's transparency helps. Forestry, agroforestry as well is a big one, particularly when it comes to understanding the state of a forest, anticipating the value, anticipating risks such as windstorms, etc. But then the agricultural part there as well, being able to distinguish with agricultural commodities and crops, and to understand, well, what is the likely yield and impact, and then finally, and to like to put into bucket of more like kind of infrastructure, what is mining again. If you build, if you mine, what is the likely impact, where should you, how should you, etc. So industries that are really impacted by rapid change, and that are really requiring more, let's say, what if scenarios and simulations to understand what could be going on and what is going on really.
You've obviously had to talk to non-scientists when you were either doing a fundraise, and in future you will be talking to people like governments. How do you explain the value of the technology to people who are not data scientists?
So everyone, whether data scientist or not, is aware of the impacts or consequences of climate change, natural disasters, geopolitical events. And I think at this date and time, highly aware, really. So when you look at talk about consequences historically, even just in the past year, really, and then look at what would more transparency give us, or what could it be? How could it have helped to know what scenario A, B, C, D could have been? To have technology that would be able to anticipate that, almost create an overlay on all the data that is out there to be able to get more transparency, to anticipate. And that's usually what people that are not from a technological tech world, let's say, or the AI world, what resonates, because it's something that impacts all of us, whether we work in AI, whether we work in data science, we work in Earth observation or not. Ultimately, we all have to live with what is going on around us, and getting some tools to help to better understand. I think we will all benefit from them.
If this technology becomes widely adopted, as we hope it would, what do you think will be the first changes we'll see in the real world?
I mean, hopefully there's, I'm doubling down on the transparency part of it. Hopefully I think that's the most important. And that has, that can be applied in so many different scales, right? On a citizen scale, local governments, local authorities, governments, large industries. So if you're able to understand, potential, challenges in your supply chain, potential challenges in your agricultural crop yields, potential impact on the energy supply to certain towns, right? So that those are decision-making tools. And then I would hope that with more transparency, repeating myself here, but with more transparency, people would become more aware, and people would consider more about, what a certain decision what impact it could have.
Well, you say you're repeating yourself. I say you're reinforcing a very important point. We're getting to the end of the first part of our interview. So, for people who can't wait until to find out more, where can they find out more about Another Earth?
Well, and then Earth.ai, a website. There's a big blog section there as well. That with feeding quite a lot. There's LinkedIn. There's more and more media engagements here as well, such as Web Summit Rio. Also more industry specific conferences, but also more general, I guess, human machine interactions, AI conferences that we're participating to really spread the word.
Maya Pindeus, for the moment, thank you very much indeed.
Thanks very much, Guy.
And that's it for the first part of this interview, but there will be more. Come back next week when we'll talk about an awful lot of other subjects, how this relates to the real world, future risk, and how to stop organizations treating prediction as certainty. Or maybe that's a good idea. We'll find out next week in part 2 of this interview. Thank you for listening.